Friends, in this video we are going to discuss about a previous year GATE question on electronics device. As you look into the question, you can see that a diode has been given and the P region of the diode is highly doped where Na is too much greater than Nd. That's why the width of the depletion layer in the P type is very thin, whereas the width of the depletion layer in the N type is of the order of 0.2 micrometer. And the N side, the doping concentration is 10 to the power 16 per cc, and the permittivity of the epsilon is given by 1.044 into 10 to the power minus 12 farad per centimeter. So we have to find the approximate peak electric field in the kilovolt per centimeter at the junction. Now if we draw the electric field profile, we know that the electric field profile will look like this. So this is the E max value. So we can say that the E max will occur just at the junction of the semiconductor diode. So we can assume or we can neglect this thin region of depletion region inside the P plus side. So we can say that the E max is occurring at the near about the junction middle point or the junction point. So let us see that for an abrupt, so it is an abrupt P plus N junction, and we know that E max is given by a equation Q into Nd into Xn divided by epsilon s, because the Na value is very much greater than Nd, so Xp value will be very much smaller than Xn, and Xp value is the width of the depletion layer in the P side. So we can neglect the value of Xp. So from this equation, if we find the value of E max, we can find it as Q is equals to 1.6 into 10 to the power minus 19. Nd value is given by 10 to the power 16 and Xn value is given by 0.2 into 10 to the power minus 6, that is in micrometer, and epsilon is given by 1.044 into 10 to the power minus 12. So if we do the calculation, it will come as 30.65 kilovolt per centimeter. So this will be the value of the electric field at the junction point for the given semiconductor diode. Thank you.